In the last video, we looked at how we compute the average value of a function over a given interval, but we didn't really get into a whole lot of examples, and so I wanted to just set aside one video just to work through a complete example where we find the average value of a function over some interval. So here we go. Our function is x cubed plus 2, and I want to find its average value that it attains on the interval from -1 to 2. So here's the cubic function x cubed plus 2. And so if we take away everything other than that interval here from -1 to 2, what we're looking for is the average y value that it attains over that interval. So it'll be somewhere between f of -1, which looks like it'll be 1, and f of 2, which looks like it'll be 10. So we plug in -1 and 2 to get those y values. So the average value is somewhere in the middle, but where is it exactly? Well, turns out we had a formula for this, and it used a definite integral. Now, if we just took the definite integral of the function over the interval, that wouldn't give us average value. As we know, that would give us the area under the curve, the total area, that is. We need this extra little part, this 1 over b minus a, this part right here, then it's responsible for dividing that quantity by however long your interval is. That's what b minus a is. And that is the average value that the function attains over that given interval. So let's try this with our function. So our function is x cubed plus 2, and the interval is -1 to 2. So we'd have 1 over 2 minus -1, that's 1 over b minus a, times the integral from -1 to 2 of our function x cubed plus 2. So we have an integral to compute, and then we have a fraction to tack onto that as well. So this would make 2 plus 1, the minus the negative, so we'd have 1/3, and then the integral of, well, I'll tell you what, let's just go ahead and do it right now. Well, we need to integrate x cubed plus 2. So this will be x to the 4th over 4, and then plus 2x, bracket with a -1 to a 2. And so we'll leave the 1/3 on the outside here. And then we're going to plug in a 2 and then plug in a -1 and subtract. We're using the fundamental theorem of calculus here. Alright, so when we plug in a 2, let's see if we can do some of this math mentally here just to save some time. Plug in a 2, let's see, we get 2 to the 4th is 16. 16 divided by 4 would make 4. And 2 times 2 is 4. So 4 plus 4 makes 8. So if you plug in a 2, we should get 8. Now, how about plugging in -1? -1 to the 4th is +1, so this would make 1/4, but then we would be subtracting 2, right? So plus 2 times -1, minus 2. So 2 would be 8/4, so net total, that would be -7/4, if my math is correct, -7/4. Alright, so we have 1/3, and then we have to subtract, or actually add, these two fractions here, 7/4, and let's see, 8, if you found a common denominator, would be 32 over 4 to get a common denominator, but 32 over 4 is still 8. And so we'd have 1/3 times 39 over 4, 32 over 4 plus 7 over 4. And then 39 is divisible by 3, so final answer would be 13 over 4, which as a decimal would be actually exactly 3.25. 3.25. So if you look up here, yeah, 3.25 is between 1 and 10. And notice it probably is a little closer to 1, because if you notice, it looks like it spends a little bit more time hanging out a little on the lower end than it does just very briefly. It very quickly rises up to 10. So yeah, this answer sounds very, very reasonable here. And so that's the average value that it attains on that given interval here. And my picture's not really to scale, so don't really look at the picture and say, well, it looks like it should be a little bit higher based off of the way I drew it. My drawing is not really to scale. But this answer here really does sound very reasonable.